Imagine you're walking down a dark corridor. Suddenly, you hear a sharp noise. In a fraction of a second, your heart and breathing quicken, your pupils dilate, your muscles tense. It's not your imagination playing tricks on you, it's a survival program switching on. Your senses send the information to a large relay hub packed with neurons in the middle of the brain, the thalamus, the brain's central station. From there, two routes emerge. The fast track sends a simplified signal straight to a crucial cluster of neurons in the fear circuit, the amygdala. The amygdala is the brain's danger detector. It sets off the alarm in your body without waiting for details. The slower route climbs to cortical areas, visual or auditory regions, then the associative cortex and the prefrontal cortex. These refine the analysis, confirming, qualifying, or canceling the alert. So the amygdala can launch the reaction before you even know exactly what you saw or heard, then the cortex catches up and reframes it. Within the amygdala, the basolateral nucleus, the input side, compares the signal with memories and what matters to you. The central nucleus, the output side, sends commands to the hypothalamus and the locus coeruleus in the brainstem, two other major groups of neurons. The hypothalamus kicks off the sympathetic system. The adrenal glands triggered by it release adrenaline. The locus coeruleus diffuses noradrenaline throughout the brain. The blood is flooded with adrenaline, the brain with noradrenaline. The consequences are immediate. The heart beats faster and harder, the bronchi widen, blood is redirected to the muscles. The skin and digestive tract are put on hold. The liver releases glucose, the pupils expand, vision sharpens. Sweating rises to cool the engine, reflexes tighten, and attention locks onto what may save you or harm you. Then comes the slower stage. The hypothalamus launches a chain of messengers to the pituitary, then to the adrenal glands, which release cortisol. This hormone extends the energy supply, makes blood vessels more reactive, stabilizes blood pressure, and pauses functions that can wait. Digestion, repair, reproduction, parts of immunity. In the brainstem, around a fine canal of fluid called the aqueduct, sits a small crown of neurons, the periaqueductal gray, PAG, orchestrating instinctive responses. If the threat seems distant or uncertain, it programs a brief freeze. The body stiffens for a second to assess. If the threat comes closer but an escape is possible, it favors flight, lowering the center of gravity, turning the shoulders, quickening the steps. If the threat is imminent or unavoidable, it arms the body for fight, tightening the neck and shoulders, planting the feet, fixing the gaze. It also regulates breathing, which may pause or speed up, vocalizations, which may become a cry for help, and even pain, which it can mute for a few minutes to allow action. Finally, if the situation can be resolved through appeasement, it supports social safety signals. A steady voice, slow gestures, a stable gaze, indicating to the brain that danger is receding. Meanwhile, feelings come to the forefront. The insula, a small patch of cortex tucked inside the brain, maps what's happening in the body, making you feel the heat in your chest, the knot in your stomach, the dryness in your throat. The anterior cingulate cortex, a band of cortex on the brain's inner surface, tracks effort, the clash between reflex and choice, and pushes for action when inaction costs too much. It's the coach of effort and action, the instant decision maker. The prefrontal cortex, usually great at weighing pros and cons, is temporarily constrained by noradrenaline and the amygdala. You gain speed at the cost of nuance. You focus, you simplify, you cut through. Memory shifts into useful mode. The amygdala tags the event as a priority. The hippocampus records the context in space and time. The hippocampus is a thin strip of cortex in the temporal lobe, builder of new memories and maps of places, the where and when of our stories. With a bit of noradrenaline and cortisol, the memory engraves more strongly. Very handy for avoiding danger next time. But under extreme, prolonged stress, encoding fragments, you retain vivid shards but lose the thread. That's the difference between a memory that guides and one that overwhelms. Fear isn't always a flash. Sometimes it stretches. There's no wolf in sight, but uncertainty lingers, a noise repeats, an expectation gnaws. This diffuse, sustained tone engages another nearby group of neurons, the bed nucleus of the stria terminalis, BNST, which sustains hypervigilance and anxious anticipation. It's the permanent center that keeps the alarm lit. The amygdala reacts to acute, identifiable threats. This network manages uncertainty and the maybe. They talk to each other and can reinforce one another if not reframed. At the sensory level, everything reorganizes. Sudden sounds dominate. Vision prioritizes movement and contrast. Time seems to slow because your brain processes more mental frames per second. It runs on predictions, constantly comparing what it expects to what arrives. When the unexpected breaks in, the prediction error spikes and the alarm rises. That's why clarity, light, predictability, and routines soothe. They reduce surprise and thus the alarm. The body follows simple rules. Overbreathing blows off CO2 and can make you dizzy, sometimes worsening panic. Slowing the breath with a longer exhale activates the vagus nerve and lowers pressure. Reassuring social contact calms the amygdala. Familiar places and clear landmarks tell the brain danger is fading. An open posture and slow gestures send safety signals. Post-shaking tremors are often the body's way of discharging the surge. Fear has benefits. It protects, it sharpens you, it strengthens certain useful learnings. But it has costs when prolonged or misdirected. Too much adrenaline exhausts. Too much cortisol undermines sleep, memory, immunity. In the brain, chronic alarm makes the amygdala more reactive, weakens the prefrontal cortex, and sustains vigilance loops. You see danger everywhere, you avoid, and avoidance convinces the brain the danger is real. There are exits. Understanding what's happening already breaks part of the cycle. Clearly naming what you feel reduces amygdala activity and gives control back to the cortex. Breathing calmly with a longer exhale boosts vagal tone and steadies the heart. Gradually re-exposing yourself to what you fear in safe, controlled ways teaches the brain that the dreaded catastrophe does not happen. Reframing the situation with different words changes the signal's meaning. Sleep consolidates new associations. Regular movement lowers the baseline of vigilance. Social connection acts as a biological buffer. To sum up, something startles you, the thalamus relays, the fast path hits the amygdala, the slow path brings details. The amygdala sounds the alarm. Noradrenaline and adrenaline get you moving within heartbeats. Cortisol takes over for endurance. The insula makes you feel inside. The anterior cingulate arbitrates. The prefrontal decides when it can and steps back when it must. The hippocampus records the story. When the threat passes, the vagal brake engages, hormones subside, balance returns. Fear isn't a flaw in the system. It's a rapid, brilliant program, built to save you, teach you, prepare you. It becomes a problem only when it fires too hard, too often, too long, or at the wrong target. Understanding it is already beginning to regulate it. And next time your heart races in the dark, you'll be able to read the choreography. An alarm that fires fast, a cortex that catches up, a body that mobilizes, then a calm return you can speed along by breathing better, naming what's happening, turning on the light, leaning on someone. That's science, and it's also a user's guide to your brain.